level of sound. So intensity level of sound is measured in decibels, and that too, just like the Richter scale, is a logarithmic scale. So take a look here. The intensity level measured in decibels can be modeled by this formula. You need no knowledge of physics or science or chemistry to do this problem. W is the intensity of the sound, and the units are watts per square meter. So watts per square meter. And W naught, this is the constant, 1 times 10 to the negative 12 watts per square meter, okay? And if you look here, you have W over W naught. The units will cancel, so you could take a logarithm of it, and then it'll just be in decibels. Okay, if the intensity of sound of a person talking loudly, this is 3.6 times 10 to the negative 8 watts per meter, right? A person talking loudly. That's when I really get excited about the math, and I'm probably at that intensity. What is the intensity level of the sound in decibels? Okay. So this is the intensity, so that's W here, right? I want D of W, basically. Okay, so D of W is equal to 10 log of W, 3.6 times 10 to the negative 8, over 1.0 times 10 to the negative. Please don't plug this into your calculators just now. dW is equal to 10 log. Okay, now look at this. The constant is 1 times 10 to the negative 12. So essentially you're dividing by 1 and then the exponents, right? So this here, you should be able to do by hand. All right, so this is 10 log. I'm sure you've done this in chemistry. 3.6 divided by 1 is what these days? 3.6, and then 10 to the negative 12. 10 to the negative 2 is how much? Times 10 to the power of 4. Okay, so that much you should be able to do by hand. Now, yes, you can plug it into your calculator. And now I'm going to tie it to what we're going to do next in the next lesson. So this is 10. All right, in Algebra 2, you learn that log of A times B is log of A plus log of B. You remember? Yeah. So this is log of 3.6 plus log of 10 to the 4. And there are brackets around this. Okay?
And we can do log 10 of 10 to the 4. It's just 4.
Exactly. And we know that this is just 4. So, yes, at some point we're going to, there's some calculator involved, but basically that's that much you should know. All right. So here when you plug this in, finally, you get 45, and it's 45 decibels. So just as reference, I did plug this in later, but I'm showing you basically how to break it down because this is what we're going to do next lesson. All right. So 45 decibels. So that's how, if somebody's speaking very loudly. Yeah. This would be in a calculator section. However, I'm telling you that I just want to introduce some stuff before we go into the next one. Okay, if the threshold hearing of a certain person with hearing loss is 5 decibels, so the noise level has to be at least 5 decibels for them to hear it, will a sound with an intensity of this much be audible for that person? So is that loud enough for this person to hear? Right. Well, let's see. We have to convert this into, we have to, rewrite this in decibels. So let's see. D of W is equal to 10 log 2.1 times 10 to the negative 12 over 1 times 10 to the negative 12. Oh my God, look at that. The 10 to the negative 12s cancel. So I have D of W, 10 log 2.1. Again, calculator here. And that'll be 3.22 decibels. So can the person hear? No. Right. Exactly. And it's way too low. Okay. Sound in excess of 85 decibels. So 45 decibels is somebody talking loudly, and then in excess of 85 decibels can cause hearing damage. Determine what the intensity of sound has to be with an intensity of 85 decibels. So if now this is my D of W. So I'm just gonna go right into it. 85 is equal to 10 log W over the constant. Okay. I'm going to divide by 10. So 8.5 is log W of 1 times 10 to the negative 12. Okay. Now, what is a logarithm? What is the answer to a logarithm? An exponent. So basically, if I have, log of 1,000, what I'm looking for is 10 to the what gives you 1,000, right? So basically that's what that is, right? And then that's the exponent, right? So here the answer is the exponent. So here I'm asking 10 to the what gives you this, and it's 8.5. Does that make sense? So there is a 10 here. So this is asking you 10 to the power of what is 1,000. Okay? So basically here, this, right? 1.0 times 10 to the negative 12. What is that? 10 to the power of this exponent gives me this. Does that make sense to you guys? All right. So 10 to the power of this exponent gives me that. Okay. Let's go back here again. If I have log base 1,000 is equal to 3. How can I rewrite that? 1,000 is equal to 10 to the 3, right? So this number is equal to 10 to the 8.5. Okay. Now multiply both sides by the constant. So I have 1.0 times 10 to the negative 12 times 10 to the 8.5 is equal to W. So W is 3.2 times 10 to the negative 4 watts per meter squared. 3.3, we're going to talk about properties of logarithms. All right. Now, again, what is the answer to a logarithm? An exponent. Okay. So now, take a look at this for a minute. Suppose I have log base 2 of 16. What am I looking for here? The exponent of 2, which would give me 16, right? So the answer is 4. Is that right? Now, suppose I broke up the 16 into, I don't know, 4 times 4. Okay? I'm still looking for an exponent at the very end, right? I'm looking for an exponent of 2 that would give me whatever value that is. So I can either do it in one shot, or if the numbers are really big, I could break them down. Like I could break down the 16 into 4 and 4. And now I could say, what is the exponent of 2 that gives me 4? What is the exponent of 2 that gives me 4? And then add them to each other. Does that make sense? It's better maybe if we do 32. Yes and no. Yeah, it all comes down to, manipulating numbers. So suppose it's 32. Our exponent is 5. Is that right? Okay, let me break down 32 into 8 and 4. Okay, I haven't changed anything, have I? So now I ask myself, okay, let me divide and conquer with this 32-bit. What is the exponent that gives me 8? 3. What is the exponent that gives me 4? 2. So I add them. In total, I have an exponent of 5. Right? That's where this property comes from. Because I have log base 2, 8 times 4. What did I do? Log base 2 of 8. So I found the exponent of that one. Plus log base 2 of 4. Now I found the exponent of that one, right? So if I have log of AB, that's why it's log of A plus log of B. It's not some mystical formula that some Greek guy, happened to see on some tree while he was walking through the forest. It's a very common sense, very practical view of exponents, right? That's what it is. So that's why if I have log of B, x times y, it's log B of x, the exponent that gives me x, plus the exponent that gives me y. And if I'm dividing, then I have to subtract my exponents, all right? Minus. Now, powers, if I have, so if I have log base 2 of, 32 to the power of 5, okay? Now, the exponent of just this is 5, and then I have to raise it to the power of 5. So it's like 5 sets of the exponent. So the 5 comes down, and that's how I deal with powers. Okay? All right, so let's do it this way. So I have log base 2 of 32, right? And the exponent here is 5. Is that right? Now, what if it's 32 to the power of 5? Right? What is that? What's 32 to the power of 5? It's 2 to the 5 to the power of 5, right? So what exponent do I need here? What's the exponent of 2 that would give me 32 to the power of 5? 25, right? Because 2 to the 5 gives me 32, and then to the power of 5 gives me this one. So I have 5 sets of exponents in that one. So I have to multiply everything by the 5. Okay? All right, let's go here and do this. If a logarithm is an exponent, I want to work with exponents. So log base 2, 32 to the power of half. So my half would come down. This is half log base 2 of 32. And that's half times 5, 5 over 2. Okay? All right, here we're going to do the same thing. This is 3 log 7, 49 to the 1/6. Okay? 1/6 will come down. And I have log base 7 of 49. So here, the coefficients are a half. The exponent here is a 2. So this is just a 1. Who would have thought that mess is 1? Yeah.
Could you make it like 7 squares and then log 7 and 7?
You can. I like this because, I don't know, to me it's simpler and it really states the exponent rule. Okay? All right. Here, the 4 will come down. The 2 will come down. So I have here 3 times 4. And what was ln of e? 1. Right? Because it's a base of e, and e to the power of what gives you e? That's a 1. We always say that in algebra too. In reality, ln of e is 1. So because something to the power of 1 or times 1 is the same number, in algebra 2, it's easier to just say it goes away. But technically, ln of e is equal to 1 because this is log base e of e. So e to the power of what gives you e? 1. Okay, so then here, 2 times 2, ln of e is 1. So essentially here we have 12 minus 4 equal to 8. Okay? All right. Here. Now we're going to expand these. We're going to use the properties. All right. So here we've got a product. So this is going to be ln of x squared plus ln of root e. Okay? So if the 2 comes down, 2 ln of x plus ln of e to the half, right? And here I have 2 ln of x plus what? What does that give me? 1/2. And there you have it. Whether you have to put it in, like common denominator form or not, it doesn't matter. It's the same. Okay? All right. This one. Log base 6. All right, so I'm going to combine some steps here. Log base 6 of this cube root x. But can I just write from the first step that that's x to the 1/3? Yeah? Because it's cube root of x, which is x to the 1/3. Now, anything that's in the denominator is subtracted. Anything in the denominator is subtracted. So, minus log base 6 of 36. And then again minus log base 6 y to the 4. All right? Anything in the denominator is subtracted. You could do minus and then in brackets blah plus blah. But think of it as anything in the denominator is like, the people, it's like a second class math citizen. They always get the minuses. All right? Anything in the bottom is a minus. Okay, so now this is going to be 1/3 log 6x minus 6 minus 4 log base 6 of y.
Shouldn't it be 2? 6 to the 36 is 2, right?
Yeah.
It's 2, I'm sorry. And the order here isn't really going to matter. All right? Okay. Here, okay, so look at what we have on top. ln of 2x minus 3. I put this problem here because most students want to split up the 2x minus 3, but you can't. You have to be able to recognize that 2x minus 3 is an entity of its own. So here I have ln of 2x minus 3, okay, minus ln of 3, minus ln of xyz to the 1/4. Okay? Yes. So this is ln of 2x minus 3 minus ln of 3. Now this is basically like associative or, distributive. You could do it in any order. So basically this is 1/4, right? Because it's going to come down ln of xyz. Okay? So this is ln of 2x minus 3 minus ln of 3 minus 1/4 ln of x plus ln of y plus ln of z. I have to say, if this was a test question, 80% of the time students will stop at this step, but you're not done yet, right? Each of your ln's or logs can only have one element inside, one argument. And okay, so either like this, or if you can also distribute, and it will be ln of 3 minus 1/4 ln of x, 1/4 ln of y. Okay, either one of these are okay for me, but the book might have it in different form. Okay, let's condense the other ones. Yeah, yes, Hannah. Okay, so you cannot, because the properties, you have a property for ln of a times b, and you have a property for ln of a over b, but you have no property for ln of a minus b. You cannot distribute that. It doesn't work that way. Because if you have a ln of 5 minus 3 like this is ln of 2, okay? This is not ln of 5 minus ln of 3. It doesn't equal to that, right? Just like if you had like the square root of 16 minus 9, right? What is that? Is that the same as 4 minus 3? Can you just take a square root like that? No, it's the same with ln's. Okay, you have to do the inside first and then, yeah.
Wait, on the bottom, you see, why did the 3 and the, like, why did you split up the 3 and then the 4 and that's the 2?
So here it's 3 times this, right? And just like we did over here, it was 36 times y to the 4 and we had to split it up. We do the same thing here. You have to split this times that. You have to split them up. All right? You have ln of a times b here. Okay? Yes.
Why is it like plus 1/4?
Oh, it's minus. I'm sorry. Minus is here when you distribute. Okay. Next one here. Let's condense. All right. So when you condense, you're basically, it's like you hit this. And then it's like you're going to rewind what we did here, right? So everything, you know, like it's just going to go backwards. So all of these exponents, coefficients will become exponents. Okay? So here we have log base 4, x to the half. And then here we have minus log base 4, x minus 2 cubed. Log minus log, this is division, so it's going to be log base 4, x to the half on top, which is the square root of x, and then here x minus 2 cubed. So this is log base 4 root x over x minus 2 cubed. As long as you have you should not have any negative exponents, and I do prefer them in root form just because, you know, I want to see that conversion. Okay. Here, it's going to be ln of x plus 1 to the, no, this is a cube because it's to the power of 3. If it was to the, if this was 1/3, yeah. So x plus 1 to the 5 plus ln of x to the 6 plus we multiply. So ln of x plus 1 to the 5 x to the 6. All right, and I like to put brackets because you want to know that both of those are an argument of the ln. Okay, now. Okay, here. This stuff starting here is not in your book, all right? I've added it. It's not in your book, but we're required to do it, and you will have like a handout on it in addition to the homework. It's just a couple problems. Okay. So here, we're going to, it says to factor. So we're going to factor first a GCF and see if we could go from there. All right, here we have negative 2x e to the x squared, negative 6 e to the x squared. So you see this e to the x squared term is common to both. So we're going to factor out e to the x squared. Now, if you think about factoring, if you have x to the 4 minus x squared, right? If you factor out an x squared, what do you get from this first term? Okay, x squared y. What are you doing mentally that you're not even aware of, but it's second nature, so you do it? Essentially, when you're factoring out, you're dividing by that term, right? That's why you get x squared here. And then you divide by the term you're factoring out. That's why you get a 1 there, okay? So here, if I'm factoring out an e to the x squared, I factor out e to the x squared. I factor out e to the x squared. If you think about it that way, it makes it easier to see because now we're going to have to deal with like fractional and positive and negative exponents. Yeah. You can. I wanted to do that later because I just wanted to factor out the e to the x squared right now. We are going to do it though. Okay. All right. So if you factor out an e to the x squared, from here I get negative 2x. From here I factor. I get a minus 6. Right. Now we're going to take out an additional negative 2. So negative 2 e to the x squared x plus 3. When we're doing this, we would take out the negative 2 from the beginning, right? But here I just wanted us to get some practice with e first. All right. Look at this one. What are we going to factor out? Okay, I have e to the negative 4x, e to the negative x. All right. I have the same base, different exponents. Look at here. I had the same base, different exponents. Which one did I factor out? The one with the what exponent? Higher or smaller? The one with the smaller exponent. So here, between the two e's, which one am I going to take out? E to the negative, is negative x smaller or is negative 4x smaller? Negative 4x is smaller, right? If I have a number line, and if this is 0, if I have negative 1, that's here. Negative 4 times 1, that's further down. So negative 4x is smaller. That's what I'm going to factor out. And I could also take out an x. So I'm going to take out an x e to the negative 4x. So that means here I divide by those. Okay. So I'm going to get a 5, an x, and then e to the negative 4x's will go away, so it's just 1. Minus, I have a 2. The x's go away. Now here I have e to the negative x minus negative 4x, right? Because I subtract my exponents. So I have x, right? That's what I'm doing. 5x minus 2 e to the what? 3x. Okay?
Why is it negative x minus negative?
Because we're subtracting exponents.
Why?
Because if you divide, you subtract exponents. Right? You see here we're dividing. So top minus bottom, and if it's a negative, that's when we need to be extra careful. So that's what we get here. All right. Oh, what about this one? What can we factor out? We have a 7 and a 2, so nothing there. Looks like there was an x plus 1 everywhere. And then I have an e to the x minus 2, e to the x, and then here I have, oh, sorry, this didn't come out. This is an e to the x plus 1. Okay, between an x plus 1, an x, and an x minus 2, what's the smallest?
Minus 2.
X minus 2 is the smallest, so I'm going to factor out e to the x minus 2. So what I'm left with, okay, so here I factor e to the x minus 2 times x plus 1, okay, and so on. Here and here as well, okay? First term, I'm just going to get a 7 plus 2. X minus 1s will go away. And here I'm going to get e to the x minus x minus 2.
That's 2.
Okay? Plus x minus 1s will go away. E to the x plus 1 minus x minus 2. All right? So I have 7. So this is, this shows up a lot in chapter 4 of calculus, a lot. And by then you've got so much going on that, you know, this on top of it at least should be, you know, second nature to you by then. So here I have x plus 1 to the power of e to the x minus 2 times what? 7 plus 2e squared plus e to the what? E to the cubed. Okay? And we leave it that way. We just leave it that way. We don't. So it's x plus 1, and then you distribute, minus x plus 2, and that gives you 3. The e's don't go away because the exponents are there. So if the exponent turns out to be 0, then it'll be a 1, right? But if you're dealing with e to the exponent, remember the smallest number what's e to the x? It's got an asymptote at 0, so it's got to go, it can never go away, essentially. It's still going to be there. Okay, here. All right, here. Oh, yes. What do we factor out of here? A 3, an x, e to the negative 1/2, because that's the smaller one. So now, okay, I'm not going to divide by the 3 and the x, but e to the, because you guys can do that one, e to the negative 1/2, e to the negative 1/2. Okay, so the 3 and the x will divide out, and the e to the negative 1/2 will divide out, so I have a 1 plus what? Here, okay, I'm dividing by 3 and x as well, so I have 3 e to the 1/2 minus negative 1/2. So e to the 1. 1/2 plus 1/2 is a 1. So 3x e to the negative 1/2. 1 plus 3e. Okay, but I can't leave it like this because I have a negative exponent. Okay, so that's going to be, okay, 1 plus 3e, it's more, you can't have negative exponents, it's not simplified. 1 plus 3e, I'm gonna write it as 3e plus 1 because it's more conventional. So here I have 3x, this will be 1 over e to the 1/2 times 3e plus 1. Still not as cute as I want it to be. So this is going to be 3x, 3e plus 1 over root e. Okay, where? Okay, so if I have e cubed times e to the 7, what do I do? E to the 3 plus 7, and then it's e to the 10. Okay. If I have e to the 5 times e to the x, what do I do? E to the 5 plus x. Thank you. So now, if I have e to the 5 plus x, can I go backwards? Well, now I can, right? Because I told you you're gonna. So how did that come about? It used to be e to the 5 times e to the x, and that's how it became e to the 5 plus x. So everybody can go this way, but only you guys can go this way. Okay? So now we're going to go this way. Huh? I actually have never used that line before. This is the first. You guys are the first. Okay. So e to the x plus 4 then, where did it originate? Where did it come from? E to the x times e to the 4. And that's it. We don't plug e to the 4 into the calculator. We don't, like, this is good. We're good. Okay? Here then, what are we going to do? E to the, okay, times e to the ln of 4. Okay, negative exponent, not cool, not cool. So that's going to be 1 over e to the positive cosine of x. And what about this mess? What's that about? That's just a 4. So really, this is just 4 over e to the cosine x. Okay? Now, let me ask you some true or false questions. True or false? This is what calc students get stumped on all the time, but no longer because we're now covering this in pre-calc honors anyway. Okay, so ln of 1/2 is equal to negative ln of 2. True or false?
Do we have time to think about it?
I thought it was false, true.
Okay, yes, think about it, because we don't want you to, we want you to have educated guesses.
No.
Where did the negative come from?
Okay.
Yes, it is. It is.
So, can I, can I rewrite this as 1/2? Can I rewrite this as 2 to the minus 1?
Yeah.
Is 1/2 2 to the minus 1? And then does this come down? Look at that. Look at that. Often in calculus, the answer is given this way. But you get this. So you need to know to go back and forth. Okay, I have another one. I have another one. Okay, so let's just do some practice because we have a little bit of time. Let's do some practice. ln of 1 over y, right? This is ln of y to the minus 1. This is negative ln of y. Right? Look at how cute that is. Okay, so look at this one. ln of 2 over x. Look at how look at what I can do if I wanted to. Can I rewrite this as x over 2 to the minus 1, reciprocal to the minus 1? I mean, I can. It's a free country, and that's mathematically viable. So that's negative ln of x over 2. The point is, can you, within a moment's notice, go between these two forms? Can you, though? You will by tomorrow. Okay, ln of 1 over 8. Look at what we like. These are so much fun. I can rewrite this as ln of 1 over 2 to the what? 2 to the power of 3. So is that the same as ln of 2 to the negative 3? So is that the same as negative 3 ln of 2? So now the question is, can you go between that and that with minimal thinking? Right? That's what it is. Everything else is really algebra 2. Okay? That's really where it's at. That's where the fun is at. Okay? Because exponents